Okay, today in Algebra 2, I wanted to take a chance to go back and review the first part of 11.1. I think for the most part you guys understand that it's valid if it adds up to 1 and it's not valid if it has a negative or doesn't add up to equal 1. But one of the things I wanted to talk to you guys about was the number of successful outcomes. I have two questions here that are very similar to some of the questions that I gave you guys yesterday in your assignment. So the first one says, Hernando is choosing a random number between 0 and 9. State the number of successful outcomes for choosing an even number. Note, it is not asking for probability. It is not asking for the number of outcomes total. It is just asking for the successful outcomes. So what I need to do is I need to go here and I need to say, I need all the even numbers, okay? So 0, not an even number. 1, not an even number. 2 is, 3 is not, 4 is, 5 is not, 6 is, 7 is not, 8 is, and 9 is not. So I've got 2, 4, 6, and 8. So for this, oh wait, 0 is an even number. What am I thinking? Anyways, so for this, my even numbers would include 0, 2, 4, 6, and 8. My total number, so my number of successful outcomes are 5. It is that simple. I only have the one option. So if I just want an even number, I can only have 5 successful outcomes for this, okay? The next question is a little bit more complicated. Justin has to pick a marble out of a bag. There are 6 blue, 4 green, and 10 yellow. State the number of successful outcomes for choosing either a yellow or a green marble. So I need to know how many yellow or green I can pull. So I want 10 yellow and 4 green. I simply add 10 plus 4 to give me my 14 successful outcomes. Okay? We had not even gotten into mutually exclusive or not mutually exclusive yet. That is today's assignment. So for those of you who went ahead and put mutually exclusive or not mutually exclusive, you didn't pay attention to the page numbers that I told you to stop at. So today we are picking up on page 498, and we are going to talk about mutually exclusive and not mutually exclusive. So mutually exclusive simply means they can't happen at the same time. That means I can't pick, if I say I want to pick one student at random out of my class, I can't pick a girl and a boy at the same time. Those would be mutually exclusive. So I can't pick my Kyria and a boy if I'm only picking one student, okay? However, not mutually exclusive means it can happen at the same time. So if I were to pick, say, Jonathan and a boy, what are the options there? I'd be able to say, oh, I can pick Jonathan and a boy. That's not mutually exclusive because I can do both at the same time. Okay, so the big things here are not mutually exclusive can happen at the same time, and mutually exclusive can't happen at the same time. Mutually exclusive means that it has to happen on its own terms, okay? So, for these, we are going to answer what is the probability of selecting a red domino or a yellow domino. So, this is where you're getting into what is the probability. It doesn't just want the successful outcomes, it wants the actual probability itself, okay? A bag contains 12 solid dominoes, 8 red, 3 blue, and 1 yellow. What is the probability of selecting a red domino or a yellow domino? So I have a chance of selecting 8 red dominoes or 1 yellow domino. This is mutually exclusive. They cannot happen at the same time. So I've got 8 plus 1. I have 9 successful outcomes, okay? Because I can't select a domino that is both red and yellow because none of these are combined colors. So I have 9 successfuls out of my total possibility of 12. So I've got 9 out of 12, which is simply 3 over 4 or 0.75, okay? You will be allowed to write these in decimals. I will put those in if I need to. But you are only solving probability if it asks you what the probability is. Do not solve probability if it's asking for the number of successful outcomes. Now, we're going to flip over to this question. A ranch owner has 18 horses, 5 brown and white. I'm gonna pause here. The fact that it's got options that have 2 different colors in it means this is probably going to be a not mutually exclusive event, because it's going to be where sometimes if I choose one of one color, it's gonna give me another one as well. So keep that in mind. So I've got 5 brown and white, 6 gray and white, 3 roan, which means red, and 4 black and gray. What is the probability of the owner will randomly select a horse that has gray or white in its coat? So here I have to figure out what's my possibility of it being gray. Well, let me see. I've got 5 brown and white. That's not it. Oh, I've got 6 gray and white. Let me see. 3 roan. Oh, 4 black and gray. Okay, so I've got gray and white and black and gray. Now let's find out for white. Okay, so for white, I've got, 5 brown and white. And I've got, let me see, 6 gray and white, okay. And then 3 roan, 4 black and gray. Okay, so here I have 6 plus 4, which is 10, and I've got 5 plus 6, which is 11. So I can add these 2 probabilities together out of 18 total. So I've got 10 over 18 plus 11 over 18. However, did you guys notice this? I've got 6 gray and white here and 6 gray and white here. So after I add these together, there's no need to add this twice. So I'm just gonna subtract one of these 6 over 18s here. So that's gonna take away one of the overlaps. So what we are doing at this point is we are looking for overlaps. We don't want to double up on things. So it would be like before me saying, I need to take out a student that is either a boy or Jonathan. I wouldn't make that to where I count him twice, okay? So I'm gonna add together this normally. Let me move it up some. So I've got 10 plus 11, which is 21 over 18, and I'm gonna subtract my 6 over 18. 21 minus 6 gives me 15 over 18, which is 5 over 6, or approximately 0.83, with the 3 continuing, but I will be fine with just, well, it's 0.833, so let's just leave it as 0.8, okay? So 0.8, 0.83, whatever you want to put there. But if you'll notice, that is my proper probability. All I did was I took out where it was overlap. You can't count the same thing twice, okay? It would be like me going around the room and saying, oh, I have 17 kids in my class, and I count each of you like 3 times. You wouldn't let me get away with that, so we can't let you get away with this. If it overlaps, you count it initially, okay? But if it overlaps, you have to subtract it, okay? Don't subtract it twice though, because then you're completely counting out the grays and whites, and they do still count. So for this, you are going to have a couple assignments, a couple questions where you tell me whether or not it is mutually exclusive or not mutually exclusive. And then I need you to find the probability of a couple other things happening for me, okay? Please pay attention to the wording on your assignments, and I will see you guys tomorrow.